Okay, and again, you should be following along. If you did it already, which I hope you did, I hope you tried it, you just check your answers. And if you got it wrong, it's okay, you fix it. You don't understand something, you ask. Okay, that's the point of today. That's why we pushed the test, so you'd have a day to ask questions. Okay, so number 15 says, refer to this figure here on the right. Okay, name the following pairs of angles. Okay, so I want vertical angles, a vertical pair of angles. So who remembers what vertical angles are? What if I did this to help us? What if I numbered these? Okay, if you don't know the actual definition of vertical angles, which angle numbers there do you think are vertical? Nobody? Okay, the definition of vertical angles was angles across from each other at an intersection. So when two lines intersect, so there's only two lines here intersecting. These two right here, right? Because that ray, it doesn't cross through, does it? Nash? Yes, be quick though. Okay, so when you have these two lines intersecting, the vertical angles are angles across from each other. So which two angle numbers are across the intersection from each other? Those green lines intersect. Which two angle numbers are across from each other? I'm going to start calling names if nobody wants to share willingly. Will said 5 and 3. That is correct. So I'm going to mark those 5 and 3. Do y'all see what I mean when I say across the intersection from each other? They're not next to each other. They don't share a side. They're across from each other. So 5 and 3. Now, I'm not going to write 5 and 3 because I added those numbers. Those weren't there. So I need to actually name angle 5. So if I connect the dots for angle 5, what would I call that angle? Eric, just look where my mouse is going and tell me what letters. Okay. All three of them, put them together. KOP, that's it. So angle KOP. Okay, and then the other angle, okay, Christian, what would that one be? Angle 3, if I traced it, how could I name that one? MON. Very good. All right, now a linear pair. A linear pair are angles that are on a line together. They form a line. Okay, so let's look at this line KN. Now, a pair means two, right? So what two angles make this red line together? You can tell me in numbers for now. Above it, it would have to be 3, 1, 2, and 3, right? But what about below it? 4 and 5? So 4 and 5 are a linear pair, okay? So a linear pair, I need to name angle 4 and 5 accurately though, without the numbers, because I added those numbers. So let's see. Natalie, could you tell us how to name angle 5? KOP, that's the same one we used up above. That's good. Okay. Let's see. Lily, can you tell us how to name angle 4? NOP, good. Okay, so those two angles that I just named are a linear pair. They form a line together, has the word line in it. All right, supplementary and complementary. Those are the ones that people get mixed up a lot. Remember, supplementary means 180. They add to 180 degrees. Complementary means 90. They add to 90 degrees. Now, I see a 90-degree marking. Angle 1 is 90 degrees, but that's not a pair, is it? That's just one angle. So that's not what we're looking for when we say complementary angles. We want two angles that add to that. Now, if angle 1 is 90 degrees, though, wouldn't this side also have to be 90 degrees? Because they form that red line together, don't they? It'd have to be 90 and 90. So which two angles make up that 90 degree that I just drew? Two and three, right? So 2 and 3 together are going to have to add to 90. Now we need to name them correctly. Okay. Mina, can you name angle 2? LOM. Abigail, can you name angle 3? If I trace those letters, what order would they be? MON, good. Okay, so those two angles, angle 2 and 3 there, those add to 90. They're complementary. Okay, now supplementary means add to 180. I could use the same linear pair that I already used, couldn't I? A linear pair makes a straight line. That means it adds to 180. But since we already used that one, I'm gonna practice with a different one. So let's look at the other line. There's a line here, line PM. You see how 3 and 4 are together on that line, aren't they? So 3 and 4 would also be supplementary. Okay, so again, this isn't the only correct answer. I'm just picking another one because we've already used 4 and 5 together. So I want to name angle 3 and angle 4 because those together are going to add to 180 because they're on a line together. Okay. Medrano, you shut up for me. Can you name angle 3 for us? MOP is the blue. Okay, I want just angle 3. I want to turn there. So what would it be? MON or NOM. Remember, we got to keep the vertex in the middle. Okay, so if I do angle MON, that's angle 3, then how could I name angle 4? I connect those dots, connect the points. PON or NOP would both work. Again, that doesn't mean that's the only correct answer. It's one of the correct answers there. Okay, so that's knowing those angle relationships. All right, so now this next section, this next group of questions is constructions. See, these all have like the same picture as the choice, 16, 17, and 18. So they're asking, of these images, A, B, C, D, okay, which one of these is an angle bisector? Which one of them is the construction of congruent segments? And which one's the construction of a segment bisector? Okay, well, angle bisector, obviously we have to have an angle. Do y'all agree? There's no angle in image C, is there? So that's definitely out because there's no angle. Okay, the rest of these all have angles. Okay, but a bisected angle means an angle cut in half. Are there any markings on D that would lead me to believe that this is cut exactly in half? There's not. There's just 3 rays and an arc through all of it. That would not, there's nothing measured or marked to make sure that that's the exact center. Remember, the process we learned was to draw an arc through the given angle and then use the intersections that that arc creates to draw 2 other arcs that intersect out here in the middle. Do y'all remember that? Okay, and then you connect that intersection to the vertex. That's the angle bisector. That's the process for angle bisector. Okay, so angle bisector is this one here. Okay, congruent segments. Hey, these that have those angles are not anything about the segments being congruent. Remember, we set the compass to the size of the segment and then made an arc on a line, and then from somewhere on that arc to that new point, that created the congruent segment, didn't it? Y'all remember that? Oops, that's supposed to be a different color. So this is the one that's congruent segments. You'll just have to remember the process that we learned for constructions for angle bisector and congruent segment. Now this last one, we didn't actually practice this. Well, we did perpendicular bisector, okay, but segment bisector is very similar. It's what we showed here. We had segment AB, okay, and then they did the arcs from both vertices, or excuse me, both endpoints, and then connected those intersections. And this line, DE, is bisecting AB. Okay, so that was that one. Bisecting means to cut in half. So that is the construction that cut that segment in half. So these really you could kind of guess on just by if you knew the words. Angle, segment, bisect means cut in half, congruent means the same. So if you just know a lot of those terms, you would probably be able to give an educated guess and get these right, wouldn't you? Okay, so that's the vocab's really important. All right, and then on these last couple here, it says based on the construction below. Okay, so both of them give the same image. Which one is this? Is this an image of a segment bisector, a congruent segment, or an angle bisector? Yeah, these are both. This image is an angle bisector. So what's happening in both of these is an angle bisector. Okay, it says now based on that construction of an angle bisector, it tells us if angle ABC, so ABC is the original angle, ABC. Okay, so if that's 60 degrees, they want to know the measure of DBC. So that's this little one in here. Well, what did we talk about? Bisegment. Cut in half. So doesn't it mean that these are the same? These two little angles created? Okay, so the whole big angle is 60. The whole big thing is 60 degrees. What does that mean each of those pieces will be? How did you get 30? What math did you do? Divided by 2. So 60 divided by 2, because cut in half is divided by 2. Each of those would be 30. So angle DBC is 30 degrees. Okay, so if you know the whole big angle and it's bisected, bisect means cut in half, so divide by 2. Now in this one, same image, same concept, but this time they tell us that angle DBC, so this time they give us the smaller angle down here, and they tell us it's 32. What does that mean for this other small angle? Also 32. So then they're asking us for that's the one they're asking us for. ABD is the blue one. So it must also be 32. So this one was knowing if you have the big angle, you cut it in half to get the smaller ones. This one is knowing that the small angles are congruent to each other. They're going to be the same. What if this one had asked for the whole big angle? What would the whole big angle be? 64. So just make sure you're reading and being clear on what is asked. Okay, that's why it's so important to be able to name your angles, connect the dots in order. I'm happy to let you borrow colored pencils or markers or highlighters, okay, on the test so you can draw these pictures and color code like I did in the notes. Okay, got to know how to name your angles. Any questions on this page? Okay, I'm going to stop this recording here because that's the end of it. So all of these videos, there will be separate videos for the different topics, and they'll all be posted in Canvas.